Hello everyone, welcome back to the channel. In this video I want to talk about the factor theorem. So in yellow here we have a little bit about what the theorem is, and then our bullet point in black is kind of going to break it down for us in one sentence. So let's read. It says, if the remainder is 0, when a polynomial f of x is divided by a linear binomial, so x minus k, then f of x divided by x minus k is equal to q of x, so our quotient, plus 0 over x minus k, so that means we don't have a denominator. So essentially we could just write that as q of x, or just our quotient with no remainder, where q of x is the quotient polynomial. Therefore, f of x is equal to that linear binomial x minus k times q of x, so that x minus k is a factor, the factor theorem, a factor of f of x. So what does that mean? Well, in black it says a polynomial f of x has a factor x minus k if and only if f of k is equal to 0. So when we're looking at the examples, right, our first couple examples say, determine whether a linear binomial is a factor. So a linear binomial, that's going to be like x minus 2 or x plus 3, something like that. And how are we going to be able to do that? Well, there's a couple of different ways. So if we look at what we have in black here, it says if f of k is equal to 0. Okay, so for example number 1, we say, is x minus 3 a factor of f of x equals x squared plus 6x minus 2? And so for this one, we could think about, okay, it looks pretty easy if we can just plug in k for x, solve it, and see if we get 0, because that's what we're supposed to get, right? The f of k is supposed to be 0, right? Or when x is our factor for k, the y value should be 0. So let's look at it. It says, is x minus 3 a factor of f of x equals x squared plus 6x minus 12? So remember when it says x minus 3, we're going to actually set that equal to 0. So we get x is equal to 3, so k would be 3. So now one way that we could check this is we could just plug in and find the f of 3. So we get 3 squared plus 6 times 3 minus 12. So 9 plus 18 minus 12. So we get 27 minus 12, and we get 15. Okay, now, is that 0? No, right? So we're going to say no, because we didn't get equals 0 right there. So we're going to say, is x minus 3 a factor? No, right? X minus 3 is not a factor of f of x equals x squared plus 6x minus 12. So it would be a factor if we would have gotten 0 right there, but we got 15. So there would be a remainder if we were to divide this using synthetic division, which is what we're going to do in example number 2. So we can also do this by dividing our polynomial using synthetic division. So for number 2, it says, is x plus 3 a factor of f of x equals 2x to the 4th plus 10x cubed plus 11x squared minus x plus 6. So to check that, we're going to once again say, okay, x plus 3 is equal to 0, so x is equal to negative 3. So k would be negative 3. Now for long division, we can set it up like this. And remember, we're going to put our coefficients of our terms and our constant across the top. So we have 2x to the 4th, 10x cubed, 11x squared, negative 1x, and we have our constant of a 6. Remember our first term, we're just going to bring that down, so that's a 2. And we're going to divide or multiply the diagonals and add the verticals. So 2 times negative 3 is negative 6. 10 plus negative 6 would be like 10 minus 6, which is 4. 4 times negative 3 is negative 12. 11 plus negative 12 would be like 11 minus 12, so negative 1. Negative 3 times negative 1 is 3. Negative 1 plus 3 is 2. 2 times negative 3 is negative 6. 6 plus negative 6 would be 0. And this is the key right there. Our remainder is 0. So that tells us that the f of k would be 0. So for this one, we can say, yes, x plus 3 is a factor of f of x equals 2x to the 4th plus 10x cubed plus 11x squared minus x plus 6. Okay, now let's take a look at our third example. It says, show that x minus 2 is a factor of f of x equals x to the 4th minus 2x cubed plus x minus 2, then factor f of x. So we can do example 3 using synthetic division like we just did in example 2. So if x minus 2 is equal to 0, then x is equal to 2. So we can set up our synthetic division. So we have our 2, and then we're going to have 1x to the 4th, negative 2x cubed, 1x, and negative 2 as our constant. So we bring down our 1. 2 times 1 is 1. Negative 2 plus 2 would be 0. 0 times 2 is 0. 1 plus 0 is 1, 1 times 2 is 2, and negative 2 plus 2 is 0. So since our remainder is 0, that's us showing that x minus 2 is a factor. So what we know is if we were to factor our polynomial here, one of our factors should be x minus 2. So now if we take this, because it tells us to factor now, x to the fourth minus 2x cubed plus x minus 2. I see that there's 4 terms, so I could factor this by grouping. So I'm going to group these 2 terms and these 2 terms. So x to the fourth minus 2x cubed, I'm going to pull out an x cubed. And so we get x minus 2. And notice over here, I already have x minus 2. So in that case, we could always just factor out a 1. So now we have x cubed plus 1, and we have x minus 2 as our 2 factors. Now, it's not factored completely because we actually do have the sum of 2 cubes here, x cubed plus 1, because 1 is a perfect cube. So we have x minus 2, and then this would be like a would be x and b would be 1. So for the sum of 2 cubes, we're going to factor this as x plus 1, and then we're going to factor it as x squared minus 1 times x, and then plus 1 squared, which would just be 1. Okay, so that would be our complete factorization there. And if you want to review the sum or the difference, but specifically here the sum of 2 cubes, I'll put that in the cards right now. But for this video, that is the factor theorem.